Let me introduce to you Cristian Reich, the next speaker. He's an engineer from Chile with over 10 years of experience in the field of odors. He's the head of innovation of the TSG environmental group in Chile and in charge of the tech department for real-time monitoring, machine learning and big data. Is he already there? No.
Here. Thank you. Okay, can you hear me? Yeah, good, thank you. Well, thank you. It's an honor to be here. My name is Cristian. I'm in behalf of representation of TSG Environmental. For those of you who don't know it, we are a company from Chile. We have more than 25 years of track record, which give us a pretty good experience in the field. And over the years, we have been able to integrate our company to offer what we call the one-stop shop, which is like we can give our clients from diagnosis to control systems to monitoring in real time. And especially this monitoring area, which is the technology that we have as the third pillar, which is how can we use technology to prevent incidents using artificial intelligence. And that's what I'm going to talk today. But before I start, yesterday we had a lot of talk regarding the IOMS, which was pretty clear that it's not an easy task to do. So what I'm going to be showing you today is what can be done with the current state of the art. Okay? So that said, and thank you for the presentation. Just for you who don't know me, I work for 10 years abroad, mainly out of Chile. I just recently finished an MBA here in Spain, so I have a lot of love for this country, where I focused mainly in digital transformation and big data. And during this program, I was able to go into China, which gave me a very good overview of what's happening in the other side of the world. But to be honest, I still prefer cañas, tapas, and jamón ibérico much better. Today, I'm the head of innovation of the company, so I'm in charge of developing the technological aspect of the company, real-time monitoring. We're also turning with artificial intelligence. We're turning and turning off abatement systems when there's no risk, so we can save some money for our clients, and developing machine learning and big data protocols, as well as developing new products. So that said, this is the big idea. Have you ever thought that technology and big data are disrupting the scientific method? Okay, this was said by the CEO of Google Venture, and it really had a real impact on me. So how is this possible? This is the traditional scientific approach. So basically, you're going to have an hypothesis. Then you're going to run an experiment. Depending on the results of the experiment, you're either going to be able to validate the hypothesis or you're going to have to do a new one. But if your first hypothesis was not very accurate, this was going to mean that you're going to have to waste more time, and it probably will mean more expensive in the long time. Whereas the technological approach, you don't have to have an hypothesis. You just need to run a system that can capture data in real time, mostly a lot of data, hopefully. Then this will come into a machine learning model, which will give us conclusions for us that we don't even know before. And this is very, very important because it will help us save time and money, especially when there are too many variables at stake. Humans are very good on taking decisions when you have one or two variables at stake, but it's very complex when you have to try to make sense to too many variables. And this is the approach that we're going to show you that we use in a pulp mill company. This is just a pulp mill because this is the case, but this is extrapolated to every industry that you can see across the industry. So what was the problem of the pulp mill? Well, they have a lot of complaints. They had more than 20 complaints. And the main reasons for this is that they were having this late analysis. So they were always running late. So they already had the complaint when they started to do something about it. And even more, when they knew that they had a complaint, it took a lot of time to understand what had to be changed to revert the deviation. Okay? So they hired us and they asked us, can you help us in providing more agility in our response and understand where do we have to put our money to have a better return on investment. So the challenge for us was basically where and when do we have to act, and where shall they invest, okay? And let's get a bit deep in this challenge. So this is what clients normally know. I like to show this one. It's like the iceberg. So what they know is what is on top. They know that they have community complaints, and they mostly know what are the most critical areas of the plant. But the missing pieces, and the fact that we help them in, is for the community, what are the gases that are more critical for them? What are the level of emissions that they have to have in order to become a complaint? What time of exposure this deviation has to have to become a complaint? What weather conditions, etc. In the sectors of the plant, what ppms do I have to have in order to per area? What do I have per area? What gases are developed where? And what is my frequency of deviation? And what are the areas that are mostly involved in these complaints? So if we are able to run big data and get to answer these questions, then we will be able to set automatic alarms that will allow us to solve the question when and where to act in the left side, and in the right side, where do we have to keep investing. So our company, we have a team of 20 people in the innovation department, and we have developed these tools in-house. In the left side, you will see what we call the Smart Plume, which is a dispersion model, as we were showing the last couple of presentations. And in the right side, we're using gas monitoring. So we don't have IOMS. We're just measuring the raw of the information, the gas that is being emanated from each area, okay? And the question is, why do we need both of them? So every company, they have three main variables: the topography where the infrastructure is built, the emissions that they're having every moment, and the meteorology that can affect even in a more or in a higher or lower level to the community. These are the risk factors. But the ones that can be controlled are mainly the emissions, and the other that is variable is the meteorology. So let's put in one scenario where you have big emissions from the company, and the meteorology didn't change at all. It was not a risk factor. If you only run a dispersion model, you're never going to know that you had a problem in real time, because the dispersion model is going to assume that your base odor emission is always the same. In the other side, maybe it happened that even if you are running continuous monitoring, you're going to know that you didn't have any deviation, but the meteorology of the moment impacted in the way that your base emission had a worse impact on the community. And that one, we will run the dispersion model, which is called Smart Plume. Worst case scenario, you have a deviation mixed with meteorological aspects, and that's the most critical moment, okay? So what we do in our software is that we put all these inputs, so the first ones here, which we have the meteorology, which we download the WRF, or local stations. We have the topography built in, the emissions that are coming from the SmartSense lectures. We can also integrate variables from the client that are most important for them, and the community input. This goes to our artificial intelligence model, and that will allow us to provide these four things that are mostly instant alarms when you're having a deviation and where. The other impact forecast, so you can plan ahead and do something in case you can. We can turn on or off some automatic control systems and process with big data everything, so we know where we have to act, okay? So what we did with this company was, and taking the same approach that I expected before, so we installed 20 different sensors across the plant without knowing where. They gave us a sense of where are the most critical areas, and we put them all over. And we had the dispersion model system as well. As I explained you need the two tools. We ran these models, complaints started to come in, and we started to understand, okay, what are the base conditions if there's no emission? What is the level of the dispersion model that has to be impacted in each community to generate a complaint? Also, what kind of emission levels were emitted on the day of the complaint, at the moment of the complaint? What kind of gas was involved in the complaint? What time of exposure was the event that finished on a complaint? Sometimes you can have a deviation of 5 minutes that doesn't end in a complaint, but sometimes you have a 2-hour deviation, and that is fair enough for to have a complaint. Also, the weather variables, what kind of wind speed? The client thought that over 4 meters per second you wouldn't have a complaint. We were having complaints with over 5 meters per second because the emission was so high that the dilution in the trajectory to the community was not enough. Okay? So what we did basically with all of this information is that we created a matrix of quantifiable risk matrix. So most of companies normally know, but by providing data, we were able to say, okay, what exactly are the parameters that generate a complaint in methodology, with emissions, with dispersion model, with everything. And these allow us to generate these automatic alarms that were scalable. So if the event was very low, the emails or the WhatsApp were sent to the operators of the plant. But if the event was lasting longer, the email will rather go to the supervisor and scale up as long as the event was going unmanageable. Okay? We're also providing a forecast with the risk. With this quantifier matrix, we can provide a risk assessment. And then we identified areas. And this was very interesting because when we were hired, they told us, you should focus in this area. We put a lot of energy in that area, and it resulted that the problem was in the other side of the plant. They didn't know that they had a leakage somewhere in the plant. And then when we crossed the complaints with information, it came out they have a problem somewhere else. So this is a case of a study for the pulp mill, which I, as mentioned before, it can be applied to any industry. The good thing about technology is that it's agnostic, so it doesn't know where it's installed, it's just doing the job for us. But I want to finish the conversation here, which why shall we monitor in real time? So in the left side is the ecosystem that we built. So you have in one side the emissions from the company, 1 minute, and here. So that will give us the operational deviations impacting the community. We have the dispersion models mixed with the community, which will measure mostly the meteorological impacts with a base odor emission. And then if we're running both, we're going to have operational complete monitoring. And if we mix the input with all this, we can build the quantifiable risk matrix that is allowing us to do all the other things. What are the benefits of this? Well, first, we have operational continuity. We can set early alerts upon deviations. We can do automatic activation of abatement system, which we're doing currently. In compliance, also, for people who doesn't have enough complaints to have the system running fully, it's very good to have a historical record for regulatory fiscalizations or audits, internal audits to set objectives, etc., and to have automated reports in case of incidents, because it takes too long, but rather our system can tell you in one click, this is what's happening right now. Also, incident prevention with this forecast and the individualization of communities, because in a plant you have clients that are very close and others that are very far. So the emission rate is not going to be the same that is going to generate complaints everywhere. So you can individualize somehow the community surrounding the plant. And finally, the continuous improvement to identify where you have to do your investment and optimize your internal protocols. So that's it. Thank you very much, and I hope if you have any questions, here I am.
Thank you, Christian. A very clear presentation, but there are questions.
Can you
Hi.
have this water?
Thank you for your presentation. I have 3 questions, but they are brief. And maybe I missed during the presentation. So first, I would like to know which meteorological model were you use and which spatial resolution were you apply for the...
Can you...
sorry.
Sorry.
Okay.
Yeah, thank you.
The meteorological model, I would like to know which one are you using and the spatial resolution, if it's possible. Also, regarding the dispersion modeling, is your own model you develop? Okay. Well, and then, where exactly are the machine learning models apply, or in which step are you using it? Because I didn't understand that.
Okay, no problem. Thank you. So we're using a mixture of WRF, which is the typical model that is available for everybody, And we mix those with local stations in the same plants. And then it comes the fine-tuning, because so CalPath is available for everybody. Okay, it's something that it's open. We have our own tool, which is using CalPath, but then the fine-tuning, the expertise that you get in over the years, allows you to make a model that is more precise or less precise. And that's very critical for this, okay? Your second question was whether this was built by us. It is built by us. So we use CalPath as a main engine, but all the rest, the software was built by us. So we have all these developers and software engineers that we have in the company. And finally was the AI. So the AI is here, here. So basically all of the, it's not being shown, sorry. So basically I show an image where, that one. All of the inputs are going to the model. So we have a cloud that collects all the input in real time, and it's this cloud that is processing all the information and creating models that will allow to have a better output. You know, so the dispersion model goes to the cloud, variables from the client goes to the cloud, the emissions that we have with the SmartSense for the gas is going to the cloud, complaints are put in the cloud, and that's trying to mix everything up and providing a further information for the client. I don't know if that helps you understand. Yep. Thank you very much, everybody.